For chemistry with Miss Aleem. As always, please pause the video if you need more time to think about the puzzler or any of the problems we're going to do. So we're going to talk about dilutions and solutions, and your other homework is to start the rock candy lab. So you're just going to turn in notes like last week and start that lab. So last time we talked about solutions. That's when you have something dissolved in something else. Often the solution will be a solvent of water, and the solute may be a salt, it may be sugar, it may be anything else that can dissolve in water. So in chemistry, a lot of chemical reactions happen in aqueous solution, and we don't always keep a lot of those solutions in the storage compartment because it takes up too much space. So we take something in a concentrated solution and dilute it. So in a dilution, you take a solvent, you add it to a concentrated solution, and that will dilute the solution. So you may have done something like this in your own home. If you use concentrated orange juice, you add that to a pitcher, and then you add 3 more cans of water, and you mix it together, and then you have the unconcentrated regular orange juice. Okay. The formula for a dilution is really simple. M1 times V1 equals M2 times V2. Now, a few things to remember here. The capital M is not the molar mass. That is the molarity. Molarity is moles per liter. The volume could either be in liters or milliliters. If you plug in volume 1 as milliliters, volume 2 will come out in milliliters. So those two units have to match on both sides. But what happens when you take the molarity times the volume here is you will get the moles. So it's essentially saying moles 1 is equal to moles 2. So if you take a concentrated solution and dilute it, the molarity goes down and the volume goes up. So we have a practice problem here. How many milliliters of a stock solution of 2 molar magnesium sulfate would you need to prepare 100 milliliters of 0.400 molar magnesium sulfate? So we have a stock solution and we want to dilute it to a weaker solution of 0.4. If we analyze the problem here, we're going to say that the 2 molar is M1, the 100 milliliters, let's call that volume 2, and the 0.4 is the molarity 2. Now there's a kind of a hint here with the of. Often when you see a word problem in math, that of means multiply. So the 100 and the 0.4 are going to go on the same side of the equation. So here it is. So 2 times V1 equals 0.4 times 100. When you solve for V1, you should get 20 milliliters of that 2 molar solution. So please pause the video and make sure you can calculate this yourself. Now if we look at these numbers, they should make sense. So 20 milliliters of the concentrated solution has the same number of moles as 100 milliliters of the weak solution. So that does make logical sense. So I'd like you to try some problems on your own and watch a video and answer some questions. So pause the video and watch the other video. You have a few more problems to think about. Some internet research may be necessary. I would suggest keeping track of your links if you do use the internet. A few more problems here. Okay, so a few definitions before we move on to other topics. Some definitions about solubility. Saturated is a solution that contains the maximum number or maximum amount of solute. Unsaturated contains less than the maximum amount. Supersaturated contains more than the maximum amount. And you might be asking yourself, well, how can it contain more than the maximum? Well, one thing that you're going to do in the rock candy lab is you're going to take sugar and dissolve it into water, and you're going to heat up the water so that it can hold more sugar. Once that solution cools back down, there's going to be more sugar than normal. So it's going to be a supersaturated solution. I've illustrated this here with a few pictures that I took. These are oleander flowers. The top one is saturated, the middle is unsaturated, the bottom is supersaturated in terms of color. Lastly, dilute is a synonym for unsaturated, which we kind of learned about earlier. Okay, now you may have heard these terms saturated and unsaturated in terms of fats. A saturated fat contains the maximum amount of hydrogen atoms that are possible for that type of fat. Unsaturated means that there is a double bond, which means the hydrogens are not saturated. So there are fewer hydrogens than are possible. So this is called an unsaturated fat. The difference between these two, or the unsaturated fats, are more heart healthy. So if you think of something like olive oil, this bend in the molecule prevents the fat from becoming solid at room temperature. So olive oil, if you put it in the fridge, it will solidify, but at room temperature, it's a liquid. That's that little kink in the molecule is why some fats are solid at room temperature and some are not. So like butter, for example, solid at room temperature, it is saturated. Okay, so if we look at the box of any kind of food package, go into your kitchen and look for something that has a fat in it. And, well, any package, it'll tell you how much fat. So in a box of Thin Mints, they have saturated fats. They have no trans fats. They have a little bit of polyunsaturated and monounsaturated. So mono means one, of course. So the previous example here would be a monounsaturated fat. Poly means many. So there would be more double bonds in this type of fat. But most of the fats in Thin Mints are saturated. And by the way, Girl Scout cookies have tons of palm oil, which is terrible for the environment. It comes from tropical places where they burn down the forest, they plant a bunch of palm oil. All the animals that would have lived there before are killed. So I would stay away from foods containing palm oil if you can. Now lastly, there's that trans fat line on there. That's where they take saturated fats and make them unsaturated. So they put hydrogen in there and attach they take out the hydrogen and they make it trans fat, but that's not normal. That's not a normal type of fat. So in nature, fats are cis instead of trans. So if we take a look at this molecule in the middle here, you can see that the hydrogens are on the same side of this double bond versus the trans fat where the hydrogens are on opposite sides of the double bond. So the trans fats are in things like margarine, and they're terrible for you. Your body cannot process this trans fat. So, they used to think that margarine was better for you than butter. It's not. Eat the butter. Butter, your body can handle butter, but your body cannot handle trans fats. You may be aware of these prefixes too, by the way, cis versus trans. So like we think of cisgender as being someone who identifies with the same gender as their biological gender. Trans is opposite. So someone who identifies with the opposite gender than their biology would suggest. So anyway, we use the same kind of prefixes in chemistry. So that ends the regular chem notes. Honors Chem has another video. If you stuck around this long, good for you. Let's see here. Oh, one more question. Can you think of some household or kitchen items that are concentrated and some that are dilute? Also try to think of a supersaturated solution. There are some in your house, probably. Okay, here's the answer to the puzzler. It's stop. Hammer time. New. All right, talk to you next time. Oh, we're not done. Here's the answers to a couple of the questions. And now we're done. Bye.